In this video, I will document the installation of an outdoor 50 amp peak NEMA 1450 receptacle. Its primary use will be to charge an electric car, although I will use it on occasion to power a welder and also a 240 volt table saw, which is the reason I am putting in a receptacle and not hardwiring it to a car charger. Now, particularly, this video addresses the use and modification possibilities for this specific metal power outlet box and shielded receptacle assembly. It's commonly found online. The entire kit is under $30 post-paid, and it seems very popular, but it has some limitations that I want to go over with. My requirements are modest for my project. My saws and my welder draw under 30 amps of power at 240 volt, but I want to be able to provide 50 amp service as an exercise and to allow for expansion for greater needs in the future. For now, I'm charging a 2015 Nissan Leaf through a plug-in J1772 module, which is the industry standard compatible module for charge regulation. I'm going to charge it at 24 amps maximum, which will be 4 times faster than the 12 amp 120 volt plug which came with the car. The circumstances of your particular setup will vary widely based upon the topography and where the power is coming from and where you're bringing it. So, there will be some aspects of this video that will be pertinent to your project. Most of my wiring is going to be done inside the house. I will be mounting the receptacle to the side of the house near the garage. I'll be using 6-gauge wire rated for THHN and THWN. Those are the wet locations. And THHN also has a tough jacket, and it is rated for heat. These individual wires, they have a very tough jacket, and they're much better than the ones that are shielded by the Romex jacket. So you wouldn't want to take apart a Romex and just pull the wires out. You want the ones that are up to spec. But either way, the 6-gauge should be rated to carry 50 amps. Here's what the 6-gauge Romex looks like. I wedged 2 little samples in the center of the image there, and I believe the one at the bottom is, you can see it's got a thinner walled jacket, and that is the stuff that was inside the Romex. The other one with the finer strands inside that are all still pretty heavy gauge strands is also 6-gauge, and that's the THHN, THWN wire. You can get your power from the main panel. I'm going to be installing a subpanel. This particular subpanel is going to be fed by an existing 60 amp line that's running to the garage. I'm going to tap that using a bus block, but you can also just run, or I might run a fresh line from the main box to this subpanel. You'll notice this subpanel does not have a main breaker because the breaker to it is being supplied from the main panel. What you do have is the 240 volts right here. You've got the neutral line right here. It didn't come with a separate neutral ground. I had to install my own ground bus bar that's bonded to the case because we're not bonding the neutral to the case. There's not any bonding here. That's going to stay separate. We're going to have 4-wire 6-gauge cable coming here. So you're going to have your 120 potential between the neutral and the 240, and then you're going to have a separate bus bar. You can simplify your project by not putting in a receptacle. If you hardwire your car charge controller to an exterior box, not have a receptacle at all, and that'll save you from having to buy not only the receptacle, but save you from having to have GFCI protection for that receptacle. You could just go with a regular breaker instead of the much more expensive GFCI breaker. But if you want the maximum flexibility of having a receptacle, that's what I'm going for. So let's continue. This box is made in China, and it's sold stateside under various names. I'm seeing names such as VEVOR, Lens, RVGUARD, and Nylite. The model number is RM50DFPB, and the receptacle here is rated at 50 amps, and it does accommodate 6 and even 4 gauge wire, but it has thin metal construction on the inside tabs, and the screws are Phillips head. It's not sufficiently robust, in my opinion, to really torque down the 6 gauge wire and make a really secure connection that's up to the task of 50 amps. But if you were to pair it with a 30 amp breaker in your panel, and you're limiting your charge to less than that, maybe 20, 24 amps tops, then it should be able to handle that continuous draw. But to up your game, you're going to have to replace this outlet, and I'll take it out to show it to you. And you'll have to replace it by a more respected name. Leviton has a high-grade one these days. This one's made by Hubbell, and you're going to have to swap this in, which is going to necessitate drilling out this plate a little larger. Now, the box itself is pretty nice. It's ruggedly built. It's got these gasketed covers all around it, on the sides, top, not on the back. You'd have to install one on the bottom, which is probably the one that's going to be used most often, although the side ones are also going to be popular. So it's got gaskets on these to keep them watertight, but you can replace them out with these ones that have 1/2 inch, 3/4, and 1 inch knockouts on them already. Now this thing has a thing here for the cord, so the whole thing, when it's closed, it can stay closed while it's plugged in, and everything stays dry. But to accommodate this spacious receptacle area, there's not a whole lot of room here in the back for wiring, so things do get a little tight. And you'll notice, because this is top weighted, the wiring tends to be here on the bottom, although they have a top one that you can run along the sides here and run it to the and run it through. So there's no rear knockout, but you can install one in the lower area, and I'll show you how to do that. If it's down here anywhere along this area, it won't interfere with the receptacle at all. So, and it has a spring-loaded release here, and there's a little locking lug if you want to lock it. So in general, it is a nice box, but it could use some improvements and modifications, which I'll go over. What you're looking at here is 3/4 inch metal conduit, and this is what I'm going to be using in the indoors. It's for dry locations, and at that size it can accommodate up to 4 6-gauge THHN wires. You would not be able to put the 6/4 Romex through it because you have to have enough room for heat to dissipate. According to the regulations, you would need a very spacious EMT conduit. It would have to be about 1.25 inches at least, maybe 1.5 inches. So, I mean, you could run Romex through EMT conduit, but it would have to be much larger. So this is really the way to go, is to put the tough wires right through into the grounded EMT conduit. Here's a neat thing. This is a GE busway box model LW-26EB. They go for about $40 on eBay, and it's kind of neat because it allows a straight through of your existing cable if you have one, and you've got a bus connector inside and a grounding lug, and you could go straight through and tap an existing line. Another way you could do this is put it in any box. You could get a what are these? These are made by Bussmann. This is a 14002-4 terminal block. So you can then split off your 6-gauge, or you can run some fresh 6-gauge to your subpanel. Okay, check out the difference between the Hubbell and the existing one here. Yes, this will accept 6-gauge wire, but as I mentioned before, you've got these Phillips head screws instead of being able to torque it down with actual Allen bolts. And then take a look at the thickness of the copper in here compared to here. you're coursing a lot of current if you are running this at 40 amps or 42 amps continuous in a 50 amp circuit. So, you know, I would not do it. And I think what you need to do if you are going to put a 50 amp breaker in your panel, so it'll be feeding 50 amps to this thing without cutting out, you need to swap this in. So obviously we're going to have to unscrew this, take this out, and swap in a proper one. And I think this has, I'll check the diameter of that. I think it's 62 millimeter, but I'll double check that. Let's take this thing apart and then we'll drill it out. Okay, I have a Milwaukee hole dozer set, and this 2.5 inch 64 millimeter will do the trick. It's just going to have a little bit of a gap right here as it comes through, because it looks like this is a 62 millimeter. So for this project, I got an actual 62 millimeter bit, and that should be much better. Now, once this thing starts turning here, I'm sure it's going to start biting, and it's going to want this thing to spin. So I'm going to anchor this down with a couple of these 1/2 inch screws so it doesn't want to go anywhere. And then preferably, if you had a drill press, use that. If you're hand holding a drill, when it hits this thing, it's going to want to do some run out. So it might be better to use a very hard wood so your anchor stays put, or put a thin sheet of metal under this so it stays in the metal. But definitely anchor this down and use a drill press if you have it, because then you'll have a little bit better control over it. When you're drilling, don't forget this is the bottom, and that's where your room is for wiring. So when you do your drilling, try to center weight this so it's a little bit higher, like it's up here, is what you'd be looking for, like in this area. You don't want to eat into your bottom area, because that's where your precious area of wiring in the back is. So let's go ahead and anchor this thing down so it won't spin around. Here it is drilled out with that 62 millimeter bit. In retrospect, I probably should have put some oil on it so it was a cleaner cut. It's not too bad, but I had to use a Dremel to polish it up a little bit so it didn't have a sharp edge. This is meant to go on the junction box of one of those Hubble outlets, and it's got the screw holes in the right direction. They're not square, they're oblong, so you're going to want to orient it lengthwise this way. And we'll put it on here so we have exactly where it's going to go, and then we'll use a permanent marker to mark exactly where here I'm supposed to drill these out. So as you can see, I did top weight it a little bit. For one thing, I didn't want to have a jagged hole there, so I completely ate through the other hole clean and left that one there. And I think that's looking pretty good. So let's go ahead and do the cutouts. Okay, with this done, we're going to see another modification that's possible, putting 3/4 conduit in through the back of the chassis. This is fed from underneath, and I've drawn on here where it will be in the back, and this goes pretty far back. Don't forget that this plate sits here to give ample room for the plug and keep it out of the weather. And so this plug goes almost to the back. You don't have much room back there, but you're not back feeding it anyway. You're feeding it from underneath. So they have access panels on the bottom, on the sides, and on the top in the rear section. If you had wires coming in this way, you wouldn't have them go directly in. You need extra wire in there for expansion, contraction due to weather. So you'd be running them around and up. And if you went in through the back the same way, you would be running them around and up one way or the other. But you don't have a whole lot to work with. You've got a ground bar here with a bonding screw. So if you're going to put your 3/4, you could probably put it here, or you could go anywhere between here and here and put it. Time for a little bit of fitment and diplomacy. That's just about where I want the box to be. So now I'm going to ascertain on the back of the box where I need to put my knockout for the waterproof EMT connector. I situated the hole for the conduit to line up with the lower part of the unit, and so I've ascertained that we're going to put it in this area over here. Once again, I have a hole dozer set, and it looks like 28 millimeter or 1 7/64 is about the right size. But looking at the conduit connector, it looks like it's a little big. So I went out and bought a 27 millimeter, which I think is going to be the right size to punch through there. I think this time I'll use a little bit of oil and put it on a drill press and press it through. If you're running conduit out the side, you're probably going to be using one of the varieties of waterproof conduit, not the EMT, but I'm running it through the back directly into the house. Whatever you use, you're going to have to get the appropriate compression connectors that are ring type and attach it. This is the EMT type, so you'd be getting a different type if you were running it out through the weather. So here it is your watertight seal, and then it's got a compression ring on the inside and another seal inside here, and that is what's going to connect it to the conduit inside the house through the 3/4 inch connection. Okay, it's installed. Let's run the wires through from the conduit in the basement, and we'll get this NEMA 1450 wired up. Regular wire strippers are not going to go down to 6 gauge. It's too big. I got this one from Klein Tools. It was inexpensive, and it's made in the USA, and now it's going to make stripping the 6 gauge wires very easy. You'll see that I've already attached the ground wire to that bus bar that's bonded to the box. And I've rolled around the other wires so the excess is not kinked or anything, and they're pointed in the right direction to go into the receptacle. I just need to add one more wire from the bus bar of the ground to also go to the receptacle, and then tighten everything down to torque spec. These should be tight. You don't want to have a loose connection in here, especially with the kind of current that will be going through these 6 gauge wires into your Hubble 50 amp. So after you've snugged everything down and you're ready to put everything away, that's when you go around and you do a last check just to make sure that everything is nice and tight. I just noticed this gasketed top plate offers a neat little window into the wiring. And you can see what I did. I went in through the back, through the bottom, rolled them around in there, and then came up through and attached them. And I did retorque each one before final assembly. And it's looking pretty neat in there. Very nice. I'm happy with it. All right, time to put this back together and run inside to complete the hookup. I'm going from the front and working my way to the source. The conduit comes in and follows this floor truss in that corner, running across, and this is where the box is going to be. If you have a panel, you go to that. I'm going to a subpanel. Your subpanel needs to be at least, well, it has to be under 6'6" off the floor from the top of the box down, so it's reachable. It needs 6'6" of headroom, so the ceiling above it needs to be at least 6'6" from the ground, and you need 3 feet in front of it so you have access to it. I'm going to anchor the box to a stout piece of 3/4 inch plywood that I'm going to anchor to the wall. I'm going to drill out the wall and use these anchors made by Cully. They use, I think the drill bit is going to be 3/8, and it's going to have to be a concrete drill bit. Then you can just drop these right in. You drill to the appropriate depth, so these are just below the surface. and then you drive in a pin that flares the back and really anchors it into the concrete. This becomes very, very strong. I have some of these in a slightly larger size on a tire changing unit that I bolted to the floor in the garage, and the thing is incredibly strong. Here I didn't have to go that high a gauge. I'm using these that you can use 1/4 inch in diameter, 20 pitch. Your standard screws, machine screws can go right into this. So we're going to drill this out and put on a 3/4 inch plywood sheet onto that wall. The plywood sheet is going to be maybe a couple of inches larger in each direction than the panel itself, so the panel has plenty of room to mount on the board. Re-drill your board for where you want the mounting to go, and then use a standard drill to make marks on the concrete so you know where to put your anchors. And don't over drill the wall. You don't want to have these anchors to sink in too far. Other than that, it's going to create a lot of dust, so have a vacuum cleaner ready and have a tarp or a tray to catch the dust. I'm not sure if I mentioned it, but if you have a hammer drill, put it on the hammer setting. It'll make your life a lot easier. I had forgotten how much I don't like drilling through concrete, and this is a really tough concrete, but didn't have to go too deep, and it's done. Now all I've got to do is wire up this subpanel and then feed power to the subpanel. It's got I put a 1-inch strain relief in it for the input from the Romex, and it's got the 3/4 out going to the conduit. And I'm going to tap at this box for 1 or 2 other sundry items. So let's get this wired up. Here it is wired into the panel. You have your THWN wires coming through this conduit, which is EMT conduit. You have the 2 hot leads, the red and the black, going to the hot leads of this 50 amp GFCI fuse. The load neutral is going to the neutral, and the ground wire, which is the green one, is going to the ground bar. You have a neutral bar that is isolated from the ground bar, and that has a lead from the GFCI, and that's going to that ground bar there. And this is the test for the GFCI right there. I have a 4-outlet adapter attached, and it's saying it's correct. And when I do a GFCI test on either one leg or the other leg of the 220 by pressing the GFI test button, it immediately goes out. And the fuse box in the basement has protected from ground fault. So the ground fault is working on both legs of the 240 relative to ground. So that's working correctly. Well, that's the end of the installation. This charge controller was only $40, really an outstanding buy. It has the unfortunate, regrettable name of Shock Flow. Purportedly, it's a 50 amp charger or a 40 amp charger, but I don't know if I can trust those specs. It has only a 10 gauge cord coming out of it, so it should be good for 24 amps, which I have it set at. And the 2015 Nissan Leaf, which I have parked out here, the cord even reaches, even with it parked nose in. Let's go ahead and plug her in. Right, it is charging. And our readout here is telling us that it is charging at a rate of 23 amps at 240 volts, with a maximum of 24 amps on the charge controller. So that's 4 times as fast as the factory 120 volt 12 amp charger that's in the trunk. So now charging is going to be much, much faster. And this is a really nice installation. Really pleased how it turned out.